Welcome to this session. In this session, introduce the concept of linear equations. We'll start by defining what we mean by linear equation, give examples of linear equations, and then do a few examples involving determination of solution of linear equations. So, definition. So, a linear equation is any equation of the form a1x1 plus a2x2 plus a3x3 plus anxn equals to b, where a1, a2, a3 up to an are real numbers called coefficients of the variables x1, x2, x3 up to xn respectively, and b is also a number called the constant term of the equation. So it should be noted that x1, x2, x3 up to xn are variables, and they can be any other letters. You can as well use y1, y2, y3 up to yn, or z1, z2, z3 up to zn. So if we have an equation of this form, where the variables, there are no products of variables and the highest power of each variable is 1, this is called a linear equation. So we can give examples. So give examples of linear equations. So we can have x1 plus 2x2 equals to 6. We can also have 3x1 plus 3x2 plus 4x3 equals to 10. We can also have 3x plus 2y equals to 7. We can also have a half x plus y minus pi z equals to √3. We can also have x1 minus 3x2 plus 10x3 plus 7x4 equals to 0. We can also have sine pi over 2 x1 minus 4x2 equals to e raised power 3. So these are examples of linear equations. Examples of nonlinear equations. So equations of the form, for example, if we have x1, x2 plus 3x2 equals to 6 is not linear because of this product of x1 and x2. If we have b, x1, x2 plus x3 equals to 12, is also not linear because of the product x1 and x2. E raised power x plus 2y plus 3z equals to 14 is not linear because of this e raised power x. Sine x plus 2x plus 2y plus 3z equals to 10 is not linear because of sine x. And e 1 over x plus 1 over y equals to 10 is also not linear, because if you put the left-hand side over the same LCM, you'll have product xy. And you can give as many non-examples as you can. So after defining a linear equation, then let's define what we mean by a solution of linear equation. So a solution of linear equation in n variables is a sequence of n real numbers say S1, S2, S3 up to Sn, arranged so that the equation is satisfied when the values of the variables add x1 equals to S1, x2 equals to S2, x3 equals to S3, and xn equals to Sn are substituted into the equation. So that's what we call a solution of a linear equation. So for example, the equation x plus 2y equals to 4 is satisfied when x equals to 2 and y equals to 1. So we can say x equals to 2 and y equals to 1 is a solution to this equation x plus 2y equals to 4. Note that also x equals to -4 and y equals to 4 and x equals to, so this one, x equals to 0 and x equals to y equals to 2. And when you say x equals to -2 and y equals to 3 are also solutions of that same equation, x plus 2y equals to 4. Now just know that the reason why we are saying that these are solutions is, for example, in this case 1, when you replace x for 2, so we'll have 2 plus 2 into y replaced by 1, we'll have 2 plus 2 by 1 is 2, which is 4. So you see that left-hand side equals to right-hand side, which is 4. So similarly, when you put x for -4, we'll have -4 plus y 4, 2 times 4. This will give you -4 plus 2 times 4 is 8. So -4 plus 8 is 4. So you check that the left-hand side will be the same as right-hand side. So that's what we call a solution to the given linear equations. Now, let's define what we call a system of linear equations. So a finite collection of linear equations in the variables x1, x2 up to xn is called a system of linear equations in these variables. A system of linear equations in these variables. So for example, this we write a11x1 plus a12x2 plus a13x3 all the way plus a1n xn equals to b1, a21x1 plus a22x2 plus a23x3 plus a2n xn equals to b2, and then a31x1 plus a32x2 plus a33x3 plus a3n xn equals to b3, all the way up to an1x1 plus am2x2 plus am3x3 plus amn xn equals to bm. This one is called a system of m linear equations in n variables. And then a solution to this system is a sequence of numbers that satisfy the system. S1, S2, S3, all the way up to Sn, that is a solution of each of the linear equation in the system. So for instance, if we have 3x plus 2y equals to 3 and minus x plus y equals to 4 is a system of two linear equations in two variables, x and y. Now, if we replace x equals to -1 and y equals to 3, is a solution to this system, since if we put x for -1 in equation 1, we'll have x minus 1 plus y, which is 3. So this will give us -3 plus 6, which is 3. So left-hand side equals to right-hand side, which is 3. So it's a solution to the first equation. And then for the second equation, we'll have -1 plus y is 3, -1 is +1 plus 3, which is 4. And you see left-hand side is the same as right-hand side, which is 4. So both x equals to 1, -1, and y equals to 3 are solutions to the two equations. So therefore, x equals -1 and y equals to 3 is a solution to this system. So remember that a solution to the system are the values of the variables that satisfy all the equations in the system. So if you get a set of values for x and y that satisfy only one of the equation but fails to satisfy the other equation, then that doesn't qualify to be called a solution to the given system. So let's define what we call equivalent equations. So two equations are said to be equivalent if and only if they have exactly the same solution. So we can give examples, e.g., the equations x plus 3 equals to 7 and 10 minus x equals to 6 are equivalent equations since each has 4 as its solution. So x plus 3 equals to 7, x 10 minus x equals to 6 are equivalent equations because if you solve each of them, you get 4 for x. But the equation for x plus 1 equals to 5 and 2x plus 3 equals to 1 are not equivalent since if I call this equation 1 and this one equation 2, equation 1 has x equals to -1 to be +1 as the solution, while equation 2 has x equals to -1 as the solution. So since the value for x in this equation is not the same as the value for x in this other equation, so then these are not equivalent equations. Now what we are going to do in the next session, we are going to solve a series of linear equations in 1 variables. And then thereafter we'll be solving systems of linear equations involving 2 variables. Thank you.